Hi and welcome to the fourth and final video in a video series on asynchronous programming in C#. This video is also part of the sixth tutorial in an advanced C# course. This video is a continuation of the last three videos in this video series on asynchronous programming, so please view each of the preceding videos in this video series before viewing this video. I have included a link to each of these videos below in the description. In this video, we are going to look at how to use a CancellationTokenSource object to explicitly cancel an asynchronous task or many asynchronous tasks in code before the relevant task or tasks have completed using one CancellationTokenSource object. For more content on advanced C# concepts and much more, please consider subscribing and please ring the bell so that you'll be notified of future content released from this channel. Right, so to gain an understanding of how we are able to implement code to cancel one asynchronous operation or multiple asynchronous operations using one CancellationTokenSource object, let's look at a practical code example. So I'm going to base this code example on an example included in the Microsoft Docs. So please navigate to this URL. A link to this URL has been included below in the description. You can see that this web page is entitled Cancel a List of Tasks, in brackets C#. So let's first look at the Prerequisites section of this document. I want to draw your attention to the first prerequisite. So this tutorial requires the following: .NET 5 SDK. I'm actually not going to install the .NET 5 SDK on my Windows platform at this time, and we'll be creating this example using the .NET Core version 3.1 runtime. We are able to run this example using the .NET Core version 3.1 runtime, but we will need to make a small modification to the code to get this working. If you do decide to install the .NET 5 SDK, know that the version available at the time of writing this tutorial is not yet the official release. It is an RC release, which stands for Recommended Candidate. So if you install .NET 5 SDK, I recommend reading all associated content that can be found at this URL, that we can navigate to when we click the link here marked .NET 5 or later SDK. This content can guide us in, for example, which version of Visual Studio should be installed to support the current RC version of .NET 5. I also recommend reading this blog post posted by Richard Lander. This blog post can be found at this URL. For a foundational understanding of .NET 5, I recommend viewing a video created by this channel, which can be found at this URL. As always, I have included all relevant links below in the description. I'll demonstrate how we are able to implement and run this code example, so even if you decide not to install .NET 5 SDK at this time, and your latest version of the .NET runtime is .NET Core version 3.1, you're still able to follow along with the implementation of this example. To enable running this code using the .NET Core 3.1 runtime, we only need to apply one simple code modification. We'll apply this modification when appropriate. Let's look at the first paragraph on this web page. In the first paragraph on this web page, it states, you can cancel an asynchronous console application if you don't want to wait for it to finish. By following the example in this topic, you can add a cancellation to an application that downloads the contents of a list of websites. You can cancel many tasks by associating the CancellationTokenSource instance with each task. If you select the Enter key, you cancel all tasks that aren't yet complete. So we are going to base our practical code example on the example here provided in this web page in the Microsoft Docs. However, we are going to implement our code example as a UWP, Universal Windows Platform project, instead of how it is implemented in this Microsoft example as a .NET Core console application. We are going to copy aspects of the code provided in the Microsoft Code example over to our code editor in a step-by-step fashion. So let's create a UWP project and let's name our project Cancel Download Async Operations UWP. Let's set up a basic UI, user interface. So let's start by dragging a button onto our designer surface. Let's name this button BTN Cancel Download, and let's label this button Cancel Download. Let's drag another button onto the designer surface just below the button we have just added. Let's name this button BTN Download Content. Let's label this button Download Content. Let's drag a list view control onto the designer surface and position it so that the contents of the list view control will appear to the right of our buttons. Let's name this list view control LVW Output. So let's access the main page.xaml.cs file to add the relevant functionality for our UI. Firstly, let's ensure that we include all the relevant using directives. Let's copy them from the relevant section of the relevant Microsoft web page and paste them into our code editor like this. Let's then copy and paste the relevant fields like this. These fields contain an object reference variable of type CancellationTokenSource that will be used to cancel the relevant asynchronous tasks. A collection of URLs of type IEnumerable that will store the addresses of the web pages that will be downloaded by the relevant asynchronous operations, and an object reference variable of type HTTP client that will handle the connection to the relevant web pages and also handle the download functionality. So in our application, these fields don't need to be static, so let's remove the static keywords. Let's read the explanation provided under the relevant code fragment containing the fields we have just copied. The cancellation token source is used to signal a requested cancellation to a cancellation token. The HTTP client exposes the ability to send HTTP requests and receive HTTP responses. The s_URL list holds all the URLs that the application plans to process. So the next section of the Microsoft web page is an explanation of the code within the entry point of the application, i.e. the main method. As discussed, the Microsoft code example is based on the .NET Core console project template. We are basing our application on the UWP Universal Windows Platform project template, so our code implementation will be slightly different. So the main difference between our code and the Microsoft example is that the Microsoft example is implemented so that when the user presses the Enter key, this action will trigger the cancellation of the relevant operations, i.e., the operations responsible for downloading the contents of a collection of web pages. The UWP project template makes our code implementation simpler because we can leverage a button-click event handler for this purpose. So in this Microsoft example, the tasks responsible for downloading the content and outputting the relevant information about the content are invoked through a call to the method named SumPageSizesAsync. The cancellation functionality is handled in the code above this method call. The method is implemented through a lambda expression here. Code is implemented here using the whenAny method. The whenAny method basically accepts an array of task objects. So the SumPageSizesAsync method returns a task, and the relevant lambda expression responsible for the cancellation functionality is run using the task.run method, which also returns a task object. Then an array containing a task object encapsulating the cancellation operation, as discussed, this is implemented as an asynchronous method in the form of a lambda expression, and the download operation, which is implemented as a named method, are passed into the whenAny method. The task.whenAny method will complete when any one of the operations passed within the relevant array argument completes. This means that if the user presses the enter key before the download operation, i.e. which is invoked by the call to the SumPageSizesAsync method, completes, this will effectively cancel the asynchronous web page download operations and associated functionality, for example, summing up the number of bytes downloaded, etc. So we used the whenAll method in the previous video, which allowed us to run a collection of tasks in parallel without blocking the main thread. The whenAny method is similar, but the difference is that the whenAll method completes when all the relevant operations have completed. The whenAny method completes when any one of the relevant operations have completed. Like the whenAll method, the whenAny method does not block the main thread. So this means that in the context of the Microsoft example here, if the user presses the enter key before the operations invoked by the SumPageSizesAsync method complete, this will result in the downloading operations being cancelled. The cancellation operation will complete before the download operations complete, resulting in the download operations being cancelled. So we are going to implement similar code within our example. The difference is that we'll implement a cancellation button to enable the user to cancel the download operations by pressing the cancellation button, rather than implementing code to allow the user to press the enter key for this purpose. With our UWP project, we have the benefit of a rich user interface. So let's go to our code behind class, i.e. the mainpage.xaml.cs file, and write a private method that will encapsulate the functionality to add a list item to our list view control, i.e. the control we have named LVW_output. We have already written a private method encapsulating this functionality in our previous example, so let's navigate to the relevant GitHub repository and copy this private method. This URL has been included below in the description. So here we can see the relevant method named addListItem. Let's copy this method to our clipboards and appropriately paste this method within our mainpage.xaml.cs file. So we can now write the code to handle the button-click events. Let's start with the download functionality. First, let's create two private methods that are responsible for downloading the relevant content, calculating the size of the relevant content, and outputting status information to the user regarding the relevant downloaded content. So in the Microsoft Docs webpage, let's look at the section entitled Create the Asynchronous SumPageSizes method. Let's copy this method and appropriately paste the method within our mainpage.xaml.cs file. In our example, this method does not need to be static, so let's remove the static keyword from the method definition of the SumPageSizesAsync method, and let's include the private access modifier within the SumPageSizesAsync method's method definition. The next thing we need to modify in our example for the SumPageSizesAsync method is where the code writes text to the console screen. Our output will be added to the list view control that we named LVW output. So let's replace the console.write methods with a call to our private method named addListItem. We can remove the \n character sequences from the relevant text because we don't need a line feed, due to the fact that we are adding each item of text as its own item within the list view control. Let's read the brief description of this method provided within the relevant Microsoft web page. The method starts by instantiating the starting of a stopwatch. It then loops through each URL in the s_URL list and calls process URL async. With each iteration, the s_cts.token is passed into the process URL async method, and the code returns a generic task where tResult is an integer. So within the relevant Microsoft web page, let's look at the section entitled Add Process Method. So the first line in this section reads, add the following process URL async method below the sum page sizes async method. So let's copy the process URL async method to our clipboards like this and appropriately paste it within the mainpage.xaml.cs file like this. Let's remove the static keyword from the process URL async method's method definition. Let's include the private access modifier within the process URL async method's method definition. Let's replace the console.write method with the addListItem method, like this. And if you'll remember, before we started implementing this example, I spoke about one of the prerequisites for creating this code example. The prerequisite being the installation of the .NET 5 SDK. So this is the only line of code that doesn't work if we do not have the .NET 5 SDK installed, and if we are running this example using the .NET Core 3.1 runtime. So if you are running this project using the .NET Core 3.1 runtime, simply remove the argument named token from the line of code that calls the response.content.readAsByteArrayAsync method. So let me just say that it is preferable to pass in the token argument to this method, but if you don't wish to install the .NET 5 SDK at this time, we are still able to run the code by removing the token argument. This is not ideal, but we are still able to gain an understanding of the CancellationTokenSource object and how we are able to cancel one or more asynchronous operations using one CancellationTokenSource object. Let's read the explanation of this method in the relevant Microsoft web page. For any given URL, the method will use the client instance provided to get the response as a byte array. The cancellation token instance is passed into the HTTP client.getAsync and HTTP content.readAsByteArrayAsync methods. The token is used to register for requested cancellation. The length is returned after the URL and length is written to the console. So obviously where it says the URL and length is written to the console, in our example, we are instead adding the relevant text to our list view control. Okay, so let's implement the code for the button that invokes the download operations. Let's go to our designer surface and double-click on the button labeled Download Content. Let's implement the code that calls the awaitable SumPageSizesAsync method to perform the downloading of the relevant content, the calculation of the size of the content, as well as the outputting of the relevant information about the content to our list view control. So in order to call this method asynchronously, we need to include the await operator. We also need to include the async modifier within the method definition of the relevant button click event handler. Let's implement the cancellation functionality. Let's go to our designer surface and double-click on the button marked Cancel Download. Within the relevant button click event handler, let's implement the cancellation functionality. To add the operation, we can simply call the cancel method on the relevant CancellationTokenSource object. like this. Okay, let's run the code. Firstly, let's demonstrate what happens when we click the Download Content button. So let's allow the operations to complete so we can see what happens when we don't cancel the operations. We can see that the appropriate output is presented to us as each operation completes. When the content for a particular web page has been downloaded, the web page URL followed by the number of bytes downloaded is presented on our list view control. And then once all the operations have completed, we are presented with the total number of bytes downloaded as well as the time that has elapsed between the time when we started to download the content and the time that the relevant download operations completed. Great! So let's run the code again. Let's click the Download Content button, and we are presented with the relevant output in our list view control as expected. Right, let's see what happens when we press the Cancel button. And a runtime error occurs. So in order to handle the cancellation operation appropriately, we need to handle a particular type of exception. So when the cancel method is called while the asynchronous operations are running, an exception of type task cancelled exception is thrown. So we can simply include our code that calls the sum page sizes async method within try-catch code like this, and handle the task cancelled exception appropriately. So we could access the thrown exception object to access details about the exception, but in this case, we only want to output status information to the user that the operations have been cancelled. So let's do this. Let's simply add the literal text, download operations cancelled. So remember, we are passing a token object as an argument to the getAsync method here in the process URL async method. The process URL async method is called within a loop from within the sum page sizes async method. This token object allows us to trigger a cancellation of all running asynchronous tasks that reference this token object. When the cancel method is invoked on the relevant cancellation token source object, an exception of type task cancelled exception is thrown, and we can appropriately handle this exception in our code. Right, let's run the code. So let's click the Download Content button, and we are presented with the relevant output as expected. So let's see what happens when we cancel these operations. And there we have it. The task cancelled exception is thrown when the cancel method on the cancellation token source object is invoked, and we are handling the thrown exception in our custom way, i.e., in a way that suits our application. So we can see the output text, download operations cancelled, which is an expected result. Okay, so we are also able to automatically cancel the operations after a predefined duration of time. So let's say we wanted our download operations to be cancelled if they haven't completed within a specific time duration. The way we can do this is by calling the cancel after method on the relevant CancellationTokenSource object. We can call this method before the relevant operations are invoked, like this. We need to pass in the duration of time in milliseconds to the cancel after method. This number represents the time elapsed from the moment the relevant operations are invoked. So let's specify 3,500 milliseconds or 3.5 seconds. Let's run the code. And you can see that after 3.5 seconds, the relevant operations are automatically cancelled. So you can see how this functionality can be useful when we want to automatically cancel an operation or operations after a specified amount of time. Great! For further information about asynchronous programming in C#, I recommend reading relevant content provided in the Microsoft Docs. So to summarize, in this video series, we looked at Microsoft's recommended approach for implementing code to run an operation or multiple operations asynchronously, namely the task-based asynchronous pattern. We discussed that running certain relatively long-running CPU blocking operations can adversely affect the performance of our applications. To alleviate these negative effects on user experience, UX, we can run these relatively long-running CPU blocking operations asynchronously. In order to implement the asynchronous code correctly, we first need to know the nature of the operations that we wish to run asynchronously. We need to first ask the question, is the relevant operation a CPU-bound operation, or is the relevant operation an I/O-bound operation? In the first part of this video series, we focused on running I/O-bound operations asynchronously using the async modifier, the await operator, and the task or generic task object. In the second part of this video series, we looked at running CPU-bound operations asynchronously using the task.run method to run operations on background threads. We also looked at the task.waitAll method. In the third part of this video series, we looked at best practices when implementing operations in C# to run asynchronously. We also looked at the task.whenAll method and how it differs from the task.waitAll method. In this video, which is the final part of this video series, we looked at how we can provide the user with the ability to cancel one or more running asynchronous operations before the relevant operations have completed using one CancellationTokenSource object. We also demonstrated how we can automate the cancellation of running asynchronous operations after a specified amount of time by calling the cancelAfter method on the relevant CancellationTokenSource object. I hope you have enjoyed the final video in this video series on asynchronous programming in C#. The next topic in this advanced C# course will be LINQ, Language Integrated Query. For more content on advanced C# concepts and much more, please consider subscribing and please ring the bell so that you'll be notified of future content released from this channel. If you feel you have gained value from this video, please hit the like button. It will be greatly appreciated. Please feel free to share any videos released from this channel with anyone you feel may benefit from their content. I really enjoy reading your comments, so please feel free to share your thoughts with me in the comment section. As always, the code in this tutorial can be downloaded from GitHub. A link to the relevant GitHub repository has been included below in the description. Thank you, and take care.